All right, guys. So welcome to today's lesson. Um, all right. So from the results of the survey that I asked you to do last week, okay? So you guys said that you guys would like to write notes. Not everyone, but quite a lot of you said that you want to write notes. So um, and also the thing is, I haven't got much in terms of the summary questions. Okay, I haven't got a lot of things from people submitting for the last few weeks. People would do their exercise questions, but only a few would do the summary questions. So I thought it may be good for us to have a change anyway. Okay, so for the next few weeks, I would like to ask you to submit a document or picture of your notes as part of the learning task. All right, just so that because I want to make sure that everyone is writing their notes. Okay, and in the future, if we need to change this, then we can make another change. All right. Now, our two goals for this week are the first one is that we can simplify expressions using the index law for raising powers. Okay. And the second one is that we can expand single brackets and double brackets. Now, the second goal, um, for the second goal, we will be working with the Year 10 textbook. Okay, sorry for that. Um, so we will be working with the Year 10 textbook. Now, even though we're working from the Year 10 textbook, it's technically what you will be learning in Year 9. Okay, so it would be this, just think of this as a bit of an extension. All right, and I do include in the questions something for the people who just want to work on the year 8 stuff, okay? On the year 8 skill. We have done single brackets before, okay? That's year 8. So if you guys want, you can focus on that. And a double brackets would be for those who would like to extend themselves and do a bit of year 9, okay? Um, right, so assessing prior knowledge here. Our APK for today is I just want you to um, do a bit of an estimate, okay? How many ping pong balls would be able to fit into the room that you're sitting in right now? So have a think about it. Okay, look around your room. 2 minutes, have a think, and then tell me your estimates. Oh, okay, 30 more seconds for people to think about it. How many ping pong balls would be able to fit into the room you are sitting in right now? Oh, looking at my room, I'll say what? Okay, 10. All right, what do you guys think? Lani said a lot. Ryan also said a lot. Now, how much is a lot, guys? Just give me a number. Easily over 200. Come on, Shaylee. Give me a number. Janet said 1,000. Okay. Can you be just a guess? Oh, in my room right now, I would say easily 1 million. Ryan said 10,000. Shaylee said 27 million. Okay. Yeah. That's all good. It's just to get you guys to think about it, right? In the morning, you know, just give you some to, just give you something to think about and just have a bit of fun here. So Lani said probably 1.5 to 2 million. Nice, yeah. No, definitely. I think just in my room alone, and my room is not big, but I reckon that yeah, it can fit probably like a million. No sweat. All right, so let's move on with our lesson, shall we? So the first one here is about raising powers. Okay, so hopefully you guys can see my screen here. All right. So this lesson's raising power. We talk about the goal already so that we can simplify expressions using the index law for raising powers. And we've done the APK as well. So the first piece of note that I would like you to write down, okay, and you can write this down later. For now, I just want you to focus on the notes. So anything, okay, except for 0, raised to the power of 0 is equal to 1. And I've given some example here. So the number 4, 4 to the power of 0 is equal to 1, okay? X to the power of 0 is equal to 1. 73xy, right, everything inside the brackets, to the power of 0 as a whole group is equal to 1, okay? So you can see there, anything raised to the power of 0 is equal to 1. Doesn't matter how complicated it is equal to 1, okay? And there is a reason behind this. Would you guys like me to show you, or you guys are fine with this? Just let me know in the chat. Or if you have any questions that you would like to ask about these first notes here, then let me know as well. All right, Shaylee said she's all good. All right. So I'm going to move on here. Okay, so anything, again, anything raised to the power of 0 is equal to 1. So let's try some example here, okay? So first, we have 4 to the power of 0 plus 2 to the power of 0 plus 3 to the power of 0, okay? So 4 to the power of 0, so remember anything except 0 is raised to the power of 0 is equal to 1. So 4 to the power of 0 is 1, plus 2 to the power of 0 is 1, and 3 to the power of 0 is also 1. So here we have 1 plus 1 plus 1. And that's going to give you 3 as an answer. Okay? For the second one, we've got 3a in brackets, all raised to the power of 0, multiplied by bc, all raised to the power of 0, plus 7 to the power of 0. Okay? So the first group, that's 1, multiplied by the second group, that's also equal to 1, plus the last bit here, 7 to the power of 0 is 1. So here we have 1 times 1 plus 1. And 1 times 1 is 1, plus 1, okay? And 1 plus 1 is 2. And then for the third one, for the third example here, we got 5a to the power of 0 plus 6b to the power of 0 and then c. Okay, so now there's a difference between this last example with the second example. Okay, notice how this times we don't have the brackets. Okay, so that means that the power of 0 here belongs to the a only, and the same for b here. This power of 0 belongs to um, the b. Okay, so what that means is we have 5 times 1. Okay, so a to the power of 0 is equal to 1. So we have 5 times 1 plus 6 times b to the power of 0, that's 1, times c. Okay, remember that if you don't see anything between the numbers and letters, that means that there is a multiplication sign there. Okay, and 5 times 1 is 5, and 6 times 1 times c, that's going to give you 6c. Okay, so we have 5 plus 6c. And we're just going to leave it like this because we can't combine them any further. They're not like terms. All right, so I hope that makes sense there. If you guys got any questions for this, just put it in the chat, okay? Otherwise, I'll be moving on. All right, I'm going to move on here. The second piece of notes that I would like you to write later is that the index law for raising power says that a power of a power can be simplified by multiplying indices, okay? So here we have a to the power of m in brackets raised to the power of n, and that's equal to a to the power of m times n. So you can see here what we've done is we are just multiplying the powers. Okay, so the example I have here, so x squared or x to the power of 2 here in brackets raised to the power of 5, what that is what we have to do is just multiply the 2 and the 5 together. All right, and 2 times 5 is 10. So our answer is going to be x to the power of 10. All right. Now I'm going to move on with the next piece of notes before we do some more examples. Okay. When an algebraic term is raised to a power, every part of the term is raised to that power. Okay. So some example here. So if you have 3x in brackets, all raised to the power of 4, what that means is that 3 is raised to the power of 4 and x is raised to the power of 4. Okay? So the power is distributed to both of these, both the things inside the brackets there. Now, second example, we have 2 times y cubed all raised to the power of 5. Okay, so they are in brackets there. So that means that the 5 is, so the 2 is raised to the power of 5 here. And y cubed is raised to the power of 5, okay? And we have here, so again, 2 raised to the power of 5 multiplied by y raised to the power of 3 times 5, okay? So what we learned just now, okay, this is raising power by another power, so we multiply the powers together. And that's going to give us 2 to the power of 5 times by y to the power of 15. Okay, so we learned 2 new rules here, okay, for raising powers. So let's try and go through some more examples here. If you have any questions, if you want me to go back and explain anything again, just let me know in the chat, okay? So the first one, we've got 3 squared, all raised to the power of 6, okay? So remember, a power of a power can be simplified by multiplying the indices, okay? So we're just multiplying the powers. So here we got the powers being 2 and 6, so we just multiply them, okay? And 2 times 6 is 12. So we have 3 raised to the power of 12, okay? Now, second one here, we have 2 times a to the power of 5, all raised to the power of 3. So when an algebraic term is raised to the power, every part of the term is raised to that power. Okay, so every part in that bracket is raised to the power that is outside. Okay, so here we have 2 raised to the power of 3 multiplied by a to the power of 5, all raised to the power of 3. Okay, and so we have 2 to the power of 3 multiplied by a to the power of 5 times 3, and that's going to give us 2 to the power of 3 times a to the power of 15, okay? And if you want to, you can use a calculator to work out what 2 to the power of 3 is, and that's 8, okay? But I don't expect you to use a calculator for that one, all right? Because some numbers will be too big for us to actually use the calculator. It will be just better if we leave it as a power. Then for the second one, the third one here, the final one. So we are going to combine the two rules that we learned here, okay? So first, we have a to the power of 3 raised to the power of 4 multiplied by 4 times a to the power of 5, all raised to the power of 2. So first of all, I'm just going to unpack the second bracket. So every part inside the second bracket is raised to the power of 2. Okay, so we have 4 raised to the power of 2 multiplied by a to the power of 5, all raised to the power of 2. Okay, and so, and then I'll unpack the rest of the brackets. So I have a raised to the power of 3 times 4 multiplied by 4 raised to the power of 2 multiplied by a raised to the power of 5 times 2. So I have a to the power of 12 times 4 to the power of 2 times a to the power of 10. Okay, and hey, I can see that the a's here, we've got we got the same base, and we learned last week that if we have the same base multiplied together, then what we can do is just add the powers, right? So here we would have a to the power of 12 plus 10. Okay, and that's going to give us a to the power of 22. And the 4 to the power of 2, you can leave it as 4 to the power of 2, or you can use a calculator and work it out. Or you know that 4 squared is 16. Okay, so this is the answer for this problem here. Okay, again, if you'd like me to explain anything again, please let me know in the chat, and I'll explain that. Otherwise, if you need any help, okay, you can find the key ideas on page 339 and the work example on page 340. And also there is a YouTube video here for you if you need any help. All right. And then here would be your questions for this week for exercise 5K. Right. The due date is the 28th of August. Now, before I move on to exercise, the next exercise, do you guys have any questions? I know that that was a lot of information. Okay, Larissa said nope. All right, I'm just gonna put on the next presentation here. Okay, so again, guys, don't worry if you haven't understood anything, just let me know, or you can look at the notes or the textbook, and that's going to help you. Okay. All right. So our next exercise here. So this is exercise 5A from the Year 10 textbook. Okay. And this is about expanding brackets. Okay. And we have done this before. Okay. So what do you remember about expanding brackets here? And you can use the image that you have on the screen, as a guide here. Okay. So have a think about it. 2 minutes. What do you remember about expanding brackets? What are these arrows about? Have a think about it. Okay, 1 more minute. All right, so at the moment, I still haven't seen anything. Okay, anything put in chat. Um, Hopefully, people remember something, okay, about expanding brackets, especially using the arrows there as, sort of a hint of what they need to do. But if you kind of forgot about how to expand the brackets, that's all right. I'll go through it again. Okay. Um, and hopefully we can get some more practice um, for this one. Okay. So moving on here. So remember, so we learned about this before. So when you expand a single bracket, what you do is you multiply the term outside by each of the terms inside. Okay. So here I've got A on the outside, and I multiply it by B, and then I multiply it by C. Okay, so just multiply them individually, and then we can combine them later if possible. And then here we got A brackets B minus C again. Okay, multiply the A, so the outside, by each of the things that are inside. So A times B minus A times C. Okay, and then we can simplify things if possible. All right, so that's for expanding single brackets. Now let's try some example here. So we've got -2 multiplied by brackets x minus 4. Okay, so multiply the outside number by each of the thing that's inside. So -2 here multiplied by x, then bring the minus sign. Okay, so this minus sign comes from this here. Okay, so bring it down, minus -2. Okay, because we have this negative stay with the 2, so -2 times by 4. So next, what we have is negative 2 times x give you negative 2x. Now, negative 2 times 4, that is a negative multiplied by a positive. So we're going to get a negative as the answer. And 2 times 4 is 8. So we're going to get negative 8. So we have minus negative 8. Now, because we have two negatives together, or you can think of this as subtracting a negative number, that's the same as adding, okay? So the answer we have is negative 2x plus 8. Next, we have 5x multiplied by brackets 4 minus x. Right, so again, 5x multiplied 4 minus, so bring the minus sign outside, 5x multiplied by x, okay? So the number outside multiplied by each thing on the inside. All right. So all good there, Shaylee. Again, later, because I'm recording this session, you can have a look at this video again. All right. Okay, so 5x times 4, that's going to give us 20x. Okay, minus 5x times x. So here we've got x times x, that's x squared. So we have 5x squared. Okay. And we're going to stop here because these cannot be combined anymore. They're not like terms. And then finally, we got x multiplied by 5x minus 1 in brackets minus x multiplied by brackets 2 minus 3x close brackets. Okay, so this is the last one here is going to be a tricky one. So first, we're going to multiply this x here by the 5x and the x by the 1. Okay, so x times 5x, bring the minus sign down, then x times 1. Okay, and then we have minus, this is minus x times 2, then bring this minus sign down. And now the thing is, this one we have another minus here, and that's come from the minus x before. Okay, minus x times 3x. Okay, so it's again, this one is a bit of a tricky one. And so x times 5x gives us 5x squared minus x times 1 is x minus x times 2 is 2x minus, okay, negative x times 3x. So here we've got a negative times as positive. So that's going to give us a negative as the answer. And x times 3x gives us 3x squared. Okay. Now again, we've got two negatives here. So that's the same as a positive. All right. So I'm going to change things here. And then I can see that I've got this 5x squared and this 3x squared. They're like terms, so we can combine them together. And these two, minus x and minus 2x here, we can combine them together. And we get 8x squared minus 3x. Okay. I know that this bit of a lot there, so if you have any questions or if you want me to explain anything again, just let me know. All right. Moving on here. So this is the new bit. Okay, this is a bit of an extension bit. So to expand double brackets, this is we call the FOIL method. Okay, and the FOIL method stands for first, outer, inner, last, as you can see in the picture down here. Okay, so what that means is that you multiply the first terms of the brackets. Okay, so you can see here the first term of the brackets is x in each of them. So multiply them together, that's going to give us x squared. Then you multiply the outer. So the outer for the first bracket here is the x, and the outer for the second bracket is the 5, okay? So plus 5x. Then we multiply the inner terms. So 8 times x, that's give us 8x. And then we multiply the last terms. So 8 and 5, that gives us 40. Okay, so we call this the FOIL method. Now we can also use another method here called the grid method. Okay, so what you have to do is to create a grid like this. And what's happened here is you fill in. Okay, so this, the x, then put the x in here and put the plus 4 in here. Then for the second one, you put we got x plus 7, so you put the x here and a plus 7 here. All right. And then what you do is you multiply the terms in pairs. So x times x, that's give us x squared. Then you have 4 times x, that's give us 4x. Okay, so this is doing the first row. And then for the second row, we got x times 7, that's give us 7x. And then 4 times 7, that gives us 28. So then we just put everything together. So x squared plus 4x plus 7x plus 28. And we can see that the 4x and the 7x can be combined together. So we have x squared plus 11x plus 28. Okay, so I'm teaching you two methods here. You may be thinking, which one do I use? Which one do you have to use? Okay, so you can make that decision yourself. Okay, so for some people, they find the FOIL method easier. For some people like me, okay, I use the grid method because I can visualize everything. Okay, so it's up to you which one you want to do. All right. So moving on here, let's try some examples. Okay. So first one, we have brackets x plus 2, close brackets, multiplied by brackets x plus 5, close brackets. Okay, so using the FOIL method, so using the FOIL method, we've got first, right, x times x, then outer, x times 5, then inner, 2 times x, and then last, 2 times 5, okay? And that gives us x squared plus 5x. Oh, what happened there? X squared plus 5x plus 2x plus 10. So combine the 5x and the 2x together, we get x squared plus 7x plus 10, okay? Again, you can also use the grid method. So put the x in here, put the 2 in here, put the x and the 5 in these slots here, then multiplying the terms as pair, okay? So x times x is x squared, 2 times x is 2x, x times 5 is 5x, and 2 times 5 is 10. All right, and then you can see that it's going to give us the same thing as the FOIL method. Next one, we got x minus 2 all squared. Now, let's think about it. So square means that it's multiplied by itself, right? So we have x minus 2 times x minus 2. So using FOIL method, first, x times x, outer x times negative 2, all right? So the tricky bit here is that we got a positive x, that's where this plus come from, positive x, times by a negative 2. Okay, then the inner, we've got a negative 2, that's where this minus come from. Negative 2 times x, then we got negative 2, that's from here again, okay? Negative 2 times another negative 2. So x times x is x squared. X times negative 2 give us negative 2x. Negative 2 times x gives us another negative 2x. And minus 2 times negative 2 is negative 4. Two negatives together, that's going to give us a positive. So we have x squared, and combine everything else, the like terms, we have x squared minus 4x plus 4. Okay. Again, here's the grid method. That's going to give you the same thing. Okay. And finally, we got these brackets here. 3x plus 2 times 3x minus 2. So the following method, first 3x times 3x, outer 3x times negative 2, inner 2 times 3x, and last 2 times negative 2. Okay, oops, I kind of there. Okay, so that's what we're going to get. And so then that's going to simplify down to 9x squared minus 6x plus 6x minus 4. Okay, and the minus 6x plus 6x, that's going to become 0. Okay, so let's think, if you lose $6 and then you earn $6, so in the end, you break even, right? So we can simplify everything down to 9x squared minus 4. Okay, and here's the grid method. So this is how you would expand double brackets. Okay, I know that this one is a bit harder than the one that we've done with the single brackets. So take it easy, follow the steps, okay? And I promise that you'll be able to do it, okay? If you have any questions, just let me know. Email me, okay? Or put in the chat there, and I'll explain everything again, okay? Now, this is it for the lesson, all right? If you want, there's a bit more to this PowerPoint, but that's really extension, okay? If you want to stay for that, I'm happy for you to stay and listen, okay? If not, if you think that, okay, I'm fine here, I'm gonna go and do my work, then I'm happy for you to do that as well, all right? So I'm just gonna give people about like 30 seconds, probably just 10 seconds to make the decision, all right? Bye, guys. All right, Larissa, bye. Have a good day. Okay, so for those of you who are still staying, I'm taking that as you want to know the extension. Okay, so um, so the last two examples before, they're what we call square brackets and difference of perfect squares. Okay, and what we can do with them is that we can expand them just like a double brackets, like I show you, or you can also apply the rules below. Okay, so this is where the extension bit comes in. So for the square brackets, if you have a plus b all square, that is the same as a square plus 2ab plus b square. And if you have a minus b all square, then that's the same as a square minus 2ab plus b square. Okay? And for the perfect square, if you have a plus b multiplied by a minus b, that's the same as a square minus b square. Okay, so let's try to use these. All right, so I'm using the last two example again. So first, I can see that it's x minus 2 all square. So I'm going to use the a minus b all square. And it says that I have a square minus 2ab plus b square. So the x is going to be my a, and the 2 would be my b. Okay? And so just to apply the rule here, okay? So a square, so instead of the a, I write x squared minus 2 times x times 2, okay? So this is my a squared minus 2ab, then plus b squared, okay? So I hope you can see that. And that's going to simplify to be, oh, let me just erase this for the moment. Okay, so again, this is my a, this is my b. So a squared minus 2ab plus b squared. Okay? And so I'll get x squared minus 4x plus 4, which is the same thing, the same answer that we got before. And then for the second one, right, we got a plus b times a minus b. So we can see here we got, this is our a with 3x, and this is our b. Okay, so we got a plus b, a minus b. So applying the rule here, we're going to have a squared minus b squared. And so our a is 3x, so it's 3x squared minus b squared. Our b is 2 here, so 2 squared. And the 3x squared, okay, we learned how to raise the power. So that gives us 3 squared x squared minus 2 squared. So 3 squared is 9. So that's give us 9x squared minus 4. Okay, again, exactly the same answer that we had before. So you can use either method. Okay, for this method, for this rule, you just need to memorize these two rules here. And if you see x, something a plus b squared, then you use the other rule. Okay, so a squared plus 2ab plus b squared. Okay, so I hope that this helps you. All right. All right, thank you for joining the lesson.